Hello again, Math 1 students. This is section 12.2, Congruent Polygons. And this is going to be an introduction to these congruent triangle proofs. It's going to be a little cumbersome today, a lot of steps. Don't worry, the steps will get shorter when we get to the next few sections. So today we're going to identify and use corresponding parts, mainly of triangles, and then learn what the third angles theorem is. All right, so two geometric figures are congruent if and only if a rigid motion or a composition of rigid motion maps one of the figures onto the other. So if you remember from chapter 11, a rigid motion included a translation where you move it up or down, left or right, it's called a slide, or a rotation where you spin it, or a reflection where you mirror it or reflect it. None of those things will change the shape itself. It just moves it, spins it, reflects it. Now, rigid motion maps each part of a figure to a corresponding part of its image. So basically, you have two shapes that are congruent, the same size with the same angles, and sides are going to match with each other. Angles are going to match with each other. So because rigid motion preserved length and angle measure, corresponding parts of congruent figures are congruent. Now what this means in terms of congruent polygons, corresponding sides and corresponding angles are congruent. So we'll see what this means on the next few slides. So starting with angles, we have triangle ABC and triangle DEF. Now you will notice that corresponding angles are congruent. Congruent angles will have the same number of markings. So if you look at A and D, both of them have one angle mark, and they're congruent. So angle A is congruent to angle D. Angles B and E each have three congruent marks. So I'll circle this in blue. Therefore, angles B and E are congruent. They correspond with each other. Finally, with angles C and F, both of those have two congruency marks. They are congruent. So basically what this means is congruent angles have the same number of markings as the angles in another triangle, and they go together. They're corresponding angles. They match up. We can do the same thing with corresponding sides. Now again, you will look at the hash marks. You will see that AB has two hash marks and DE has two hash marks, so AB is congruent to DE. You will also see that BC with one hash mark is congruent to EF. It has one hash mark. And then finally, AC is congruent to DF. So which this means is that corresponding sides are congruent. The sides match up with each other. So if you were basically to spin DEF and reflect it and put it on top of triangle ABC, A would be on top of D, B would be on top of E, C would be on top of F, and the triangles would match each other perfectly. So when you write a list of corresponding vertices in the same order, that's a congruent statement. So how would you write a congruent statement for these two triangles? Now what this means is that the angles have to match up with each other. So you can't just write the triangle letters in any order. They have to correspond. They have to match. And the easiest way to do it is to use the angles. So triangle ABC is congruent to triangle DEF because A goes with D, B goes with E, and C goes with F. The letters have to be in the same order such that the angles match each other in order. So you can also say that triangle BCA is congruent to triangle EFD. You can also say that triangle CBA is congruent to triangle FED. It doesn't matter what one of the letters order is as long as the other triangle matches the order in the same way. So notice the reds go with the reds, the blues go with the blues, the greens go with the greens. They have to match up. And this is really important because if you were to write triangle ABC is congruent to triangle EFD, that would be incorrect because A does not correspond or match up with E. So 1A, write a congruent statement for the triangles. Identify all pairs of corresponding congruent parts. So this is going to be a little tedious. I'm just going to go very quickly. If you don't feel the need to write this down right now, that's fine. You can probably pick it up. So what you want to do is match up the angles with each other to write a congruent statement. So let's just start with angle J. So notice that J goes with T because both of them have two tick marks. K is next. It has three tick marks, just like S, and then L goes with R. So you could say triangle JKL is congruent to triangle TSR. You could also say triangle JLK is congruent to triangle TRS. It doesn't matter what the first triangle letter order is, as long as the second one matches it by corresponding angles. Now in terms of corresponding angles, angle J is congruent to angle T, angle K is congruent to angle S, angle L is congruent to angle R. Corresponding sides, JK is congruent to TS. Now in this case, the letter order doesn't matter as long as the segment is the one you're talking about. So JK and ST both have one hash mark. KL is congruent to SR, and LJ is congruent to RT. So go ahead and try 1B. We're going to do another congruent statement and identify all pairs of corresponding congruent parts. So the angles are M goes with Y. Again, notice the two angle markings. N goes with X. P goes with Z. So those are the congruency statements on the screen. The sides are MN is congruent to YX. Both of those have one hash mark. NP is congruent to XZ with two hash marks. MP is congruent to YZ with three hash marks. So you could say that triangle MNP is congruent to triangle YXZ. Again, you could have chosen a different order for the first triangle. You could have put PMN, but then the second triangle would have had to be ZYX. Again, make sure the letters match in order so that M goes with Y, in this case N goes with X, and P goes with Z. All right, example 2. DEFG is congruent to SPQR. Solve for X and solve for Y. So what you're going to do is first match up the corresponding parts. So FG is going to equal QR because FG is the third and fourth letters. QR is the third and fourth letters. So FG has to equal QR. So your equation is going to be 12 equals 2x minus 4. Solve for X by adding 4 to both sides, divided by 2, and you see that X is 8. Next, you're going to solve for Y. Y is an angle, so it's angle Q. So angle Q has to go with angle F, whoops, because they have to be in the same order. Erase that, circle angle F. So angle F is congruent to angle Q, so the measure of angle F has to be equal to the measure of angle Q. So angle Q is 6y plus x. Angle F is 68 degrees. So 68 equals 6y plus x. Well, you know what x is. You just figured it out in the previous part of the question. Subtract a from both sides. You see that 60 is equal to 6y divided by 6. And both sides become simplified, and y is equal to 10. So even with a quadrilateral, remember the angles match up with each other. The sides match up with each other based on the order of the letters. Next, proving polygons congruent. So to show that two polygons are congruent, you have to show that all corresponding angles and all corresponding sides are congruent. Now, we're primarily going to work with triangles, and this means you have to show that all three angles and all three corresponding sides are congruent. For now, beginning with the next section, that'll be cut in half. But for now, you need to show that all sides are congruent to all sides of the other triangle, and all angles are congruent to the corresponding angles in the other triangle. So example 3, show that triangle ABD is congruent to triangle CDB. Explain your reasoning. Now for these problems, I just want you to mainly look at it, and when we get to example 5, we're going to do a few proofs, but just follow the reasoning for now. If you don't need to write this down, that's totally fine. Just listen and rewind if you need to hear it again. So let's start with the corresponding angles. We are given that angles A and C are congruent based on the number of markings. We're also given that angles ABD and BDC are congruent. The third angle is we are going to use the alternate interior angles theorem. So it's kind of hard to see, but let's just draw this. Here is your transversal. Here are the two parallel lines. So these two angles are congruent because they're alternate interior angles because AD and BC are parallel. So that's the three angles. For the three corresponding sides, we are given that AD and BC are congruent by the markings. We are given that AB and CD are congruent in the markings. The third side is BD. It is congruent to itself by the reflexive property of congruence. So all corresponding parts are congruent. All corresponding angles, all corresponding sides. Therefore, triangle ABD is congruent to a triangle CDB. Remember, you got to get the letters in order. A goes with C, B goes with D, and D goes with B. Now, the properties of triangle congruence are the same as we saw before with regular congruence. The reflexive property, the symmetric property, and the transitive property. You can just look at those. The third angles theorem is something that I mentioned in the previous problem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So here you have angles A and D congruent and angles B and E congruent. Since two of the three angles in each triangle are congruent to each other, the third has to be congruent, mainly because the three angles always add up to 180. So if the first two angles for each triangle add up to the same thing, the remaining degrees in the third angles also have to be the same. Example 4, find the measure of angle BDC. So we are told that angle A and B are congruent by the markings, and angles ADC and angles BCD are congruent by the markings. Now, since two pairs of angles are congruent, the third pair of angles also has to be congruent. So you have basically two triangles. It might be a little hard to see. You have this one there, and you have this one there. Okay, so A goes with B, and then angle BCD goes with angle ADC, and so angle ACD, which is the third triangle, has to be congruent to angle BDC. This is the obtuse angle. So these two angles have to be congruent to each other. So you know that angle ACD, because you have a 45 and a 30-degree angle in the red triangle, they add up to 75, so the remaining angle has to be 105. If that angle is 105, then angle BDC in the blue triangle, the obtuse angle, also has to be 105 because the triangles have the same two pairs of angles. The third pair of angles has to be the same, has to be congruent. 4b, find the measure of angle P. So you know that angles A and R are congruent. So if angle A is 52, angle R also has to be 52 degrees. You also have a right angle. So by the third angles theorem, angle B and P have to be congruent. So angle B is equal to 90 minus 52. Because you have a right angle, the two remaining angles, A and B, have to add up to 90. So angle B has to be 38, which means angle P also has to be 38 degrees. So these two proofs in examples 5a and 5b are going to show you how to prove triangles congruent. Now, what we're going to have to do right now is show that 6 corresponding parts are congruent, 3 corresponding sides and 3 corresponding angles. The last statement and reason will be basically what you're trying to prove. Now, beginning with the next section, you're going to be able to cut down those 6 parts to only 3. So right now, we don't have any of those new rules, so we're going to have to show that all 3 pairs of corresponding angles and all 3 pairs of corresponding sides are congruent. So here is our plan. You need to show that all 6 corresponding parts are congruent. Now, you're given a whole bunch of congruency stuff. We're going to use other rules to figure out what's left. And you're going to see these rules come up over and over again, so it's good to see how they apply. You're given 2 pairs of congruent sides. How is the third pair of sides congruent? That leaves side AC. Well, you can see that AC is congruent to itself. It's part of both triangles, so by the reflexive property, AC is going to be congruent to itself. You're given 2 pairs of congruent angles. How are you going to show that angles B and angle D are congruent? And that's the third angle theorem. Since you have 2 pairs of angles that are congruent in the triangle, by the third angle theorem, the third angle also has to be congruent. So now that we have a plan, let's see how this proof looks. So here's the 2-column proof, statements on the left, reasons on the right. You're going to number each reason and statement so they go together, and you'll start with the givens, and then we're going to show that all 6 sides and angles together are congruent. So number 1, statement AD is congruent to CB, and that is given. Statement 2, DC is congruent to BA, and that is given. Statement 3, AC is congruent to itself. When we saw this, what's the reason? The reflexive property of congruence. So now notice that we have all 3 corresponding sides congruent. So that's half of the job done. Now we're going to move to the angles. We'll start with the givens. Angle ACD is congruent to angle CAB, and that's a given. Next, angle CAD is congruent to angle ACB, and that is also given. Final angle is angle D is congruent to angle B, and as we saw with our plan, this is based on the third angle theorem. So now notice we have all 3 corresponding angles congruent, which leads us to our final statement, which is what you are trying to prove. Triangle ACD is congruent to triangle CAB. And the reason is all corresponding parts are congruent. All three corresponding angles, all three corresponding sides. So notice the logic here. You have to make all three sides congruent, and they could be given, or in this case, you have the reflexive property, all three angles. Two of them are given. The third one, you have to use the third angle theorem. So it's very logical. You have to basically have a statement and reason for the 6 corresponding parts, and then the final statement is what you are trying to prove. Let's look at example 5b. We're going to try to prove that angles WXY is congruent to a triangle ZVY, and we're going to try to show that all 6 corresponding parts are congruent. Now you notice that in example 5a, we use the reflexive property to show that a side is congruent to itself. That's a common strategy you're going to see. In this example, you're going to see another very common strategy. So you're given all 3 pairs of congruent sides. WX, VZ is congruent, XY and YV are congruent, WY and YZ are congruent. So you don't have to worry about the sides, they're all going to be given to you. You're also given 1 pair of congruent angles. Angles X and angle V are congruent because they're both right angles. What about the other 2 pairs of angles? Well, the first thing you're going to notice is that you have vertical angles here. You have angle WYX is congruent to angle VYZ. Now, here you have to use 3 letters because you can't just say angle Y. Angle Y could be the center, the vertex of different angles. So you have vertical angles. So that means 2 pairs of angles congruent. And then you can use the third angle theorem to show that angles W and Z are congruent. So basically, use the vertical angle theorem, which is a strategy you're going to see a lot. That's going to show the 2 angles are congruent, and then the third angle is congruent based on the third angle theorem. All right, so let's quickly go through this proof. Just like in the previous one, you're going to list all 3 pairs of sides and all 3 pairs of angles with their reasons, and the final statement is what you're trying to prove. Statement 1, segment WX is congruent to ZV. That is given. Next, XY is congruent to VY, and that is also given. Statement 3, WY is congruent to ZY. And that is also given. So notice that all 3 pairs of corresponding sides were given to you. They are congruent. So we're done with the sides. Now we're going to move to the angles. Next, angles X and V are right angles. And that is also given. Now we can conclude that angles X and V are congruent. And if you remember back in chapter 8 or 9, chapter 8 really, then we had a theorem, the right angles congruency theorem. All right angles are congruent. So angles X and V are both right angles, therefore they are congruent. So notice you can't just straight away say they're congruent. You first have to establish that they're right angles because that's what you're given. And then you go on to say that the right angles are congruent. So now that's 1 pair of congruent angles. Next, we're going to do the vertical angles. So angles WYX and angles ZYV are congruent. And that's the vertical angles congruency theorem. That basically says that vertical angles are congruent. If you forgot what vertical angles are, angles across from each other when 2 lines intersect are congruent. So here you have 2 lines, this angle and this angle are congruent. Statement 7, angle W and angle Z are congruent. And that is again the third angle theorem. You have 2 pairs of angles congruent in each triangle, which means the third angles in each triangle have to be congruent to each other. So finally, triangle WXY is congruent to triangle ZVY. That is what you were trying to prove, so that's going to be your last statement. And again, the reason is all corresponding parts are congruent. So this is a very long proof. We have 6 things we need to show are congruent. Now, beginning with the next section, 12.3 and going on, we're only going to need 3. But this is basically to show you how these things work. If you have any questions on section 12.2, let me know.